Okay, so yesterday when we were solving radical equations, you had, at this point, like with number 4, you get your radical alone, which are radicals alone, but on the other side you would only have one term. And so it was very easy to go from here and raise to the second power, raise to the third power, and everything just worked out pretty nice. What's going to happen with the next few examples is they're just going to get a little bit messier. If I look at this equation the way it is, we already have the radical alone, so we're in a good place to now get rid of the radical. How do I get rid of a square root? Square. But what happens when I square is I have to square the whole expression on the left side. On the right side, the square root just cancels out. But x plus 1 squared is not the same as x squared and 1 squared. Some of you have been making that mistake. X plus 1 squared means x plus 1 multiplied by x plus 1, which means we're going to distribute this together and end up with 4 terms. 2 of the middle ones will simplify together. Is it a question, Cody? Okay, so x times x is x squared. I'm going to do the whole thing out this time, but x times 1 is 1x. 1 times x is 1x, and 1 times 1 is 1. So x squared, just like Cody said, plus 2x, but it's plus 1, not plus 2, like you said. So what you'll notice at this point is now we have introduced an x squared into the mix, which means when we solve this equation, we're going to have to use quadratic techniques. Am I going to be able to use square roots? No. I have an x squared and an x. So I have to set everything equal to 0 and either use quadratic formula, factoring, completing the square. One of those big ideas that we learned before. So I'm going to start by subtracting the 7x and the 15 so that I have this equation set equal to 0. So I have x squared minus 5x minus 14 equals 0. I do not want to have to use the quadratic formula unless I have to, so I'm going to try to factor this. Are there numbers that exist that would multiply to negative 14 and add to negative 5? Jenna? Negative 7 and positive 2 would multiply to negative 14, and those numbers would add to negative 5. So we'll write x minus 7, x plus 2. Now, how does factoring help us solve? Where do I go from here, Madison? Good. X equals 7 and x equals negative 2 by the zero product property. So these are my two solutions, but remember what we said about these equations. When I squared both sides, I might have introduced an extraneous solution. Probably one of these is extraneous. What I want to do is plug them back in to check. So I'm going to check, first of all, I'm going to check the x equals 7 by plugging it back in here. So 7 plus 1 is 8. And on the right side of the equation, we would have the square root of 7 times 7 plus 15. So that will be 49 plus 15. So square root of 64. Is that a true statement? Does x equal the square root of 64? Yeah. So the x equals 7 does work as a solution. Now I'm going to check x equals negative 2. So negative 2 plus 1, and then the square root of 7 times negative 2 plus 15. So we have 7 times negative 2 is negative 14, plus 15 is 1. So, and then negative 2 plus 1 is negative 1. Does negative 1 equal the square root of 1? No, square root of 1 is 1. Negative 1 does not equal 1, and so then this one is an extraneous solution. It doesn't actually check in the original equation. So our only solution is x equals 7. Any questions on that? All right, example 5, when we have an equation that has two radicals in it and other numbers, it gets a little bit messier. If this didn't have a +1, it wouldn't be a big deal. If I want to show you an example. If this wasn't a +1, can I square both sides? Yeah, and I would just have x plus 2 and 3 minus x be a really easy situation. But because of this +1, it's going to be more difficult. I can start by squaring both sides, since on the right I do have my radical alone. So I can start by squaring both sides. But like in the last example, what that means is I actually have the square root of x plus 2 plus 1 multiplied by the square root of x plus 2 plus 1 equals, and then on the right side, because the radical was alone, it does cancel, the square cancels the square root out, and we have 3 minus x. But on the left side, this is going to be kind of messy. We have to distribute everything together. And so when I start to distribute this together, what you're going to get is x plus 2 with the square root times x plus 2 with the square root. Well, if you multiply those together, it's going to undo the square root, right? Because you're squaring, technically you're multiplying by itself, a square root. And so when I do the first part, that's just going to free up and become x plus 2. I'm going to put parentheses around it just so you realize that's the first times the first gave me that part. Now I'm going to do the square root of x plus 2 multiplied by 1. Well, that's just going to stay the square root of x plus 2. And then I have to do 1 times the square root of x plus 2 again. So plus the square root of x plus 2. And then 1 times 1 is 1. So this is a little different notation than we've seen before. Does anybody have an idea of where I could go from here? Something I could maybe simplify. Tori? Good. You can combine these. These are like radicals. And so you can make this 2 multiplied by x plus 2. What else can I maybe combine or work with here? The x plus 2 I had in parentheses, I just put it in parentheses to show it was the first term. It doesn't have to be in parentheses. Everything's added. So look, I have a 2 and a 1. That's just going to be 3. And I have this x, which I'm just going to write them down right now, the 2 and the 1 combined to get the 3. The x I'm just leaving there for now, but what can I do here? I only have one radical left. Get everything else to the other side so I can get my radical alone and square again. And so I'm going to subtract the 3, which actually in this case, the 3's cancel out. I'm going to subtract the x. And so I have 2 square root of x plus 2 is equal to negative 2x. Cameron? Actually, let's divide both sides by positive 2. We're trying to get the radical alone. So divide both sides by 2. So we get the square root of x plus 2 is equal to negative 1x. And now that I have my radical alone, I can square both sides again. So I'm going to square. That frees up the square root on the left to be x plus 2. And on the right, if I take negative 1x multiplied by itself, negative 1x times negative 1x, that's positive x squared. So now, hopefully you have some room off to the side. This is not an easy problem. Well, maybe easy step by step, but it's a long problem. So now I have x plus 2 equals x squared. What do you think I should do from here? Cody? Okay, subtract x and subtract the 2. Set equal to 0. So let's make this 0 equals x squared minus x minus 2. How did I know to do that? I knew there was an x squared and an x in the problem. I have to use quadratic techniques. So let's try to factor. Oh, did you have a question, Cameron? Or do you know what to do next? Can you factor it, you think? So x plus 1, x minus 2, that does work because 1 times negative 2 is negative 2. 1 plus negative 2 is negative 1. So there's our correct factored form. And then we can say our zeros or our solutions. X equals negative 1 and x equals 2. Now before you circle those as your answers, let's go back and check to see if they work. So I'm going to scroll out a little so I can see my original problem. So I'm going to check the x equals negative 1 first. So square root negative 1 plus 2, and then plus 1 on the outside equals the square root of 3 minus a negative 1. I'll zoom in again. So on the left side, we have negative 1 plus 2 is positive 1. Square root of positive 1 is 1. 1 plus 1 is 2. On the right side, we get 3 minus a negative 1, so 3 plus 1, which is 4. Square root of 4 is 2. Does 2 equal 2? Yes. So I'm going to go back and circle and say x equals negative 1 is a solution. If I check the x equals 2, we're going to have square root of 2 plus 2, then plus 1 is supposed to equal the square root of 3 minus 2. So on the left side, I get square root of 4 plus 1. The square root of 4 is 2, so 2 plus 1 is 3. On the right side, 3 minus 2 is 1. The square root of 1 is 1. 3 does not equal 1, and so we'll cross out x equals 2 as a solution, and that one is extraneous. So there's a lot of steps. If you need to catch up and write that down, I'll leave that up there for another minute. Let me move it down so you can see.